Good morning, class. Today's lesson is all about finding the equation of a cubic function. Now, before we can do that, let me take you back to last year, where we had a parabola, and I gave you two x-intercept values, -3, 1, and another point on the graph. When I asked you to find the equation of the parabola, you could have done that with three methods. Either the standard form or y equals a times x minus x1, x minus x2, or with the turning point formula. When you have the two x-intercepts, we usually use this form. Now we're going to use this form as well for the cubic function because now we have three x-intercepts. Let's see how that works. I ask you to determine fx, and fx passes through 3 points and a y-intercept. So you draw your graph. We assume that it's a positive cubic function. We put in our 4 points on the graph, and now we're going to use these three x-intercepts in our standard format. We don't know what a is yet. We assumed that it is a cubic function, a positive one, but after we have worked out a, we can change the form if it's not positive. So let's start. Y equals a, x minus, and now we put in our points, -2. So a negative minus -2 becomes a +2. The next point is -1. X minus -1 becomes +1. And the last one is 4. X minus 4. To calculate this or to work this out, I'm first going to multiply these two brackets, and then I'm going to multiply the trinomial that I get here with the first bracket. Let's just put this in, x plus 1, x minus 4. I also have a y-intercept. This coordinate is x is 0, y is -8. This is an x and a y value. If I substitute that into these variables, I can work out what a is. So the y is -8 equals a, x is 0, 0 plus 2 is 2, x is 0, 0 plus 1 is 1, x is 0, 0 minus 4 is -4. Then you multiply the brackets out and you get -8 equals -8a. And we can work out that a equals to 1. So a is a positive 1. That means for fx, it really is a positive graph. Now I'm going to substitute this a back into this format so that I can multiply these two brackets and then multiply it with this bracket to get fx. Let's do that. Y equals, a has a value of 1 times x plus 2, x plus 1, x minus 4. I'm going to keep the first bracket and multiply the second 2. Then you get a trinomial of x squared minus 3x minus 4. Now you multiply this bracket. First the x with all three terms, then the 2 with all three terms, and you add all the like terms, and then you finally get x cubed minus x squared minus 10x minus 8. But this is in format y equals this. They want fx. So we must give this function a name, fx. So fx is x cubed minus x squared minus 10x minus 8. Let's say that there was a follow-up question and they wanted the values of a, b, c, and d. A will be 1. B will be negative 1. C will be negative 10. And D will be negative 8. Okay. Now let's look at our next one. Determine gx, and they give you an equation. They show you, however, that it is a negative cubic function, and we want the full function formula. So we look at what we have. We have a negative 3 as an x-intercept, and we have a 2 as an x-intercept. But you can remember from our previous lessons, if the graph turns on the x-axis, it means that that x-intercept counts for 2 x-intercepts. So we are going to put this in 2 brackets. This 2 goes here, and this 2 goes again for the second bracket. Our first bracket is x minus negative 3, so it becomes a plus 3. We already know that a is negative 1. We don't have another point or another coordinate to substitute in here. That's why they gave us the a. So y equals x plus 3. First determine the trinomial. If you multiply those two brackets, it's x squared minus 4x plus 4. Then we are going to multiply this bracket into the trinomial. So the negative 1 stays outside of the bracket. If you multiply that in and you simplify it, you'll get x cubed minus x squared minus 8x plus 12. And now I only have to multiply the negative 1 into the bracket. So y equals negative x cubed plus x squared plus 8x minus 12. But they wanted gx. So we need to name our function gx equals negative x to the power of 3 plus x squared plus 8x minus 12. And that is our answer. The last example has a little bit more body. Here I give you fx, but I give you some clues in the equation. I also tell you that the turning point is 2, 9. And I want you to calculate a, b, and fx, so the equation of the cubic function. We know that the turning point has a formula of the first derivative equals 0. That means the gradient is 0. And what does a gradient being 0 mean? It means that you are on the top of the graph and the gradient there is 0. But we also know that we can substitute the x value into this gradient or turning point formula. Therefore, I'm going to determine the first derivative where x is 2 and set it to 0. So let's quickly differentiate the given equation. It's 3ax squared plus 10x plus 4, and that must be set to 0. Now I'm going to substitute the x's with 2. So it's 3a 2 squared plus 10 times 2 plus 4, which is also equal to 0. And now we can work out what the value of a is. Here we have 4 times 3 is 12a plus 20 plus 4, so it's plus 24, equals 0. So 12a will be equal to negative 24 and a will be equal to negative 2. Now I know that a is a negative 2. And I can substitute that into my equation. Negative 2x to the power of 3 plus 5x squared plus 4x plus b. I still don't have the value for b. So to calculate the value for b, I can just substitute this turning point's coordinate into the equation. This is my x, this is my y. So y is 9 equals negative 2 to the power of 3 plus 5 times 2 squared plus 4 times 2 plus b. And if you work this out and you get b alone, b will be equal to negative 3. So now I have my a, I have my b, and I can write down the equation of fx. Therefore, fx will be negative 2x to the power of 3 plus 5x squared plus 4x minus 3. But that was not all that they wanted. They wanted fx, which I have, and they want a and b. So when you answer a question like this, always end up with a summary of all your answers. A is negative 2, B is negative 3. And there I have all my answers. Your homework for tomorrow is exercise 11 on page 49, number 1 to 4.